Okay, Bismillah. Okay folks, welcome back. Bismillahirrahmanirrahim. We're looking at question number 24. This is as far as we got to in the previous video where we run out of video space basically. We're just restarting now. So in the previous part of this video we got to work out this angle, which is 16.398. That was 78.60. That was the last part of the video. This letter was given to us 240. Now, as I said before in the previous video, in order for us to look at the area of this field, we need to know an angle and we need to know its adjacent sides. So we can use the area is equal to half A, B, C formula for working out the area of non-right angle triangles. So that will give us the area for this top triangle, and in order for us to work out the area for the bottom triangle, we can use this length with this length, which would be the adjacent sides to this angle. So in order for us to do that, we need to work out that angle, and for that we need to use a calculator. Okay, so we need to get this angle here, 136 minus the angle we worked out earlier. So we have 136 minus 16.3948 equals 119.6052. Okay, so we're going to work out this formula twice. Once for this top triangle using these two adjacent sides and angle in between, and then for the bottom triangle using these two adjacent sides and the angle in between it. So let's go for it. So here's our master formula. Just check the video is making okay. It's looking nice and lovely. Now, here the A and B don't correspond to any of these particular lengths here for the moment. A and B literally means here the adjacent sides, the sides either side of the angle. So I'm going to call this one my A and this one my B, even though it doesn't correspond to the diagram as such. That's what I'm going to call my A and B. So we have half times by the two sides, which are either side of the angle in any order, times the angle in between, and that will give me the area of the top triangle, area 1, and area 2 is equal to the same formula again for the bottom triangle, which is the second triangle on the bottom here. Again we have two adjacent sides of the angle in between. So it'll be again half times by that times by that, times by the sin of the angle in between, which is 119. Okay, now we need to work out these two and then add them up, and that will give us answer. Bismillah. Right, so here we go. We have 0.5 or a half times by 240 times by 68 times by the sin, and we give a bracket, so 78.6 close the bracket equals, so 799. Okay, that gives us that's the area of the top part. The bottom part, let's do that one now. So 0.5 times by 240 times by 95 times by sin of 119.6052 equal bracket equals okay. And we need to add up these two values to give us the area. This one and this one, we're going to add them up. So let's do them on the calculator. So we have 799.9.01 add 9911.73. So that gives us a total of 17910. So the area total is equal to 17910, 7910.74. So the answer correct is basically like this. 174. I want the answer correct to three significant figures. So 1, 2, 3. That's my last digit. That's my decider. Decider is less than 5. So leave it alone. But you don't just stop there. You must fill up all the spaces up to the decimal points with zeros. So that's 1 0. That's another 0. And you stop after the decimal point. So that would be my final answer. And it's going to be meters squared. Okay, that's lovely. I hope we've got that now nice and clearly. Sorry about the video being split into two parts. Just we got to the end of the video length and we run out of video. We're restarting this now. Okay, please get this down. Right. Now this question is a very important question. We got here transformations of functions. The diagram shows part of the curve with equation y equals f of x. So again, as I mentioned in the previous videos, previous example, y equals f of x is a generic way of saying a function. So y equals f of x could be referring to, in this case, a quadratic function. It could be referring to another question, a cubic function, or could be referring to another question as a sine function, okay, and so on. But in this case, this f of x referring to what we can see quite clearly is a quadratic function. The coordinates of the minimum point of this curve are 3, 1. So this is question number 25. Okay, write down the coordinates of the minimum point of the curve with the equation y equals f of x plus 3. So that's our original function, and then add 3. So what we've done, we've worked out the answer and then we've added 3 as an afterthought. So normally when you put 3 into our function, the output is 1. We have a height of 1. But this, what it does here, it shifts the whole graph up by 3. It's like a translation. So that 3, 1 will then go to, the 3 will stay the same as the x coordinate, but the 1 will be added by 3. So that will be 4. So we can quite clearly say this, with 3 will be the same, still 3 along the x, but the height now will be 4 because it's been added on by 3, because it's been done after the function we calculated. Now, whenever there's an increase after the function has been done, that's called a translation in the y direction. This is a decrease inside the function. When you have it inside the function, you tend to think of minus as move on towards the left, but it does actually the opposite effect. So that minus 2 inside the function means we're going to move the graph 2 places to the right. So look at the previous function, previous one. So minus 2 inside means we are going to go to the right by plus 2. So from here we're going to go across by 2. So the 3 becomes a 5, but the height stays the same. 5, 1 is the coordinates of the new point. Okay, the next one is how we think about this. Y is equal to f of half x. Now, f of x, f of half x. Now remember the half is inside the function, so it affects the numbering. Now, normally when we put, let's get rid of all this on here. Normally when we put 3 into x, f of x, when you put 3 into there, the answer is 1, which is the height, that's the output. Now if I put f of 3, it'll actually give me, sorry, if I put 3 into here, I won't be working on the function of 3, I'll be working on the function of 1.5, because half times by 3 is 1.5. So I'll actually be working out the value of 1.5, which is over here, which won't give me the minimum. So in order for us to regenerate 3, I need to put in for x 6. So half of 6 will give me 3. So I'll end up working at f of 3, which is f of 3, which will give you 1. That will give us, generate the minimum point. So in a sense, that point 3 will become 6. So y with f of half x basically means the graph will be spread out, and that will stay as the minimum point. So I'm going to say here for that one is going to be 6 and 1. So the height will stay the same, but to generate the same minimum point, we need to put in a corresponding value of 6. So it shifts across to 6. So that's the answer for part C. I think this is the last question in the paper. Question number 26. Okay, let's just quickly check on the video. Make sure it's okay. Alhamdulillah, looks good. Okay, now, question number 26. The diagram below shows the 6-sided shape. The diagram not accurately drawn, so don't start measuring it. All the measurements are in centimeters. The area of the shape, the area of the shape is 102 centimeters squared. Work out the length of the longest side of the shape. Now, what we need to do first of all, we need to work out the area of the shape. Okay, the area of the shape. Now, how do we work out the area of the shape? We need to split the shape up into 2 pieces. Okay, at least, so for example, we have, right, okay, say we split the shape up. That's part A, that's part B. Now the area of this part B will be 2x times x plus 4, that's our length, and that's our width. So area of the B part will be length times by width, which is 2x times by x plus 4 as a starting point. That's just the area of the B at the bottom. Now we need to work out the area of A. It doesn't matter if we're doing it in this particular order. That's also length times by width. Now, if you know the height here is x plus 4, and that's 2x plus 5 altogether. So if we do 2x plus 5 minus x plus 4, it will give us the height of this part here. So 2x minus x is equal to x. 5 taken by 4 is equal to 1. So x plus 1 add x plus 4, which is 2x plus 5. So the length of A is equal to 4x minus 3, and the width is over here. Down by the width, that's the area of part A. What we need to do now, we need to multiply these parts over here, multiply them out, multiply this one out, add them up, simplify it and make it equal to 102, and then solve for the value of x. So let's have a look what this gives us over here. So 2x times by x will give you 2x squared. 2x times by plus 4 will give you 8x. Now here we have 4x times by x, that will give us 4x squared. And then 4x times by plus 1 will give you plus 4x. Minus 3 times by x will give you minus 3x. Minus 3 times by plus 1 will give you minus 3. Now we need to add these up. Now this one and this one up. Let's see what we get. So we get, for example, 2x squared plus 4x squared will give you 6x squared. 8x, add 4x is 12x. 12x minus 3x will give you 9x. And then we have no other values over here. Okay, so we have here just minus 3. Okay, so we have 6x squared plus 9x minus 3. Now let's see if we can factorize this particular equation using the factorizing technique. So let's copy this equation up over here. 6x squared plus 9x minus 3. That's the equation. And we know this is the area equation, this is equal to 102. So that's the area. Area is equal to 102. Let's bring the 102 over onto this side. So we have 6x squared plus 9x minus 3 minus 102 is equal to nothing. Because it was plus 102 becomes minus 102. So now we have 6x squared plus 9x minus 105 equals 0. Okay. So all the measurements are centimeter, work out the length of the longest side of the shape. Okay. Right. Give me one moment while I just have a quick look at the origin of this paper. More paper. Just give me a moment, please, folks. Okay, right. Okay, now, in order for us to work out this question, okay, we need to work out the value of x that will give us the solution. If we try to factorize, if two numbers are multiplied give you minus 105 and add up to 9x, let's think about the factors of minus 105. What numbers times give you 105? Let's have a quick think. So we have 105, you divide by 5, that will give you 21 and 5. Okay, that's one particular number. What I'm going to do now, I know this is a calculator paper and we should work out using the quadratic equation. Okay, if we use the quadratic equation, we have a x squared and bx plus c is equal to 0. Okay, so now we can see that our a value is 6, our b value is 9, and the c value is minus 105. And then we have our formula. We have x is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. Okay, now that we worked out all the areas over here, I want to take this work off because I'm going to need to recycle space because I'm going to be running out of video space. So we have over here x is equal to minus b, so minus 9, plus minus b squared, which is 9 squared, square root of, take away 4 times by the a value, which is 6, times by the c value, which is minus 105. And all of that's going to be divided by 2 times by the a value. Okay, that gives all the solutions. Let's put that into the calculator. Let's see what that gives us. Okay, so we use the fraction button first of all. Put in a line. We don't put plus or minus in the calculator because we will put one sign in, so you put plus for the moment. So 9 add, square root symbol, then 9 squared, take away, the normal take away sign. We got 4 times by